All right, so let's talk through categorical data because the ways we approach categorical and quantitative data are going to vary just slightly. But it's going to be a big theme over the expansion of this course. In second semester, we're going to have a whole unit on proportions and a whole unit on quantitative data. So hold on to your horses because we got 9 units to go. But we'll be all right. So when looking at categorical data, we tend to look at proportions. And now, maybe you're not familiar with the proportion as that type of fancy term, but this is essentially the notation that we use. We use this little p with the hat, which stands for our sample proportion, our sample prop, and this is found by taking x over n, where x is going to be our number of successes, and it just means the number of objects that we favored, and n is going to be the total. We're going to learn a little bit more about how we define variables in this course later, but for now, a sample proportion is just going to be the number of favored outcomes over the number of total outcomes for that category. Now, the frequency is how we display these values, and the frequency of a category describes how many times that category is favored. And then a relative frequency gives us the total percentage of the sample that accounts for that specific category. So we'll use the following 4 types of graphical displays to communicate information about categorical data. And so we are familiar with bar charts, hopefully. Two-way tables might feel a little bit familiar, but this is what we're talking about here, is these numbers in here, these are the frequencies. Notice that 4 people live in an apartment and have a pet. 2 people live in a house and have a pet, and 3 people have some other type of living accommodation and have a pet. So those are the frequencies, those are the counts, those are how many people belong to that category. Now, the 2 newer displays to you might be a segmented bar chart and a mosaic plot. A segmented bar chart takes the relative frequencies. So here, notice I have my 4 classifications, and let's say I was interviewing students at the first home game and the last home game. We can see here that it's basically if you took your bar chart and you took that red out of the total number of those 5 categories added together. You took that blue out of those total 5. So each section in the segmented bar chart is the relative frequency, meaning that that purple up top, this is how many juniors out of the total sample, total number, this is the number of seniors out of the total sample that were there. So it could be like 20% of those entire 100 students that we interviewed were seniors. And then maybe this is like 30%. So 30 juniors out of the 100 students, 30 students out of the 100 students we interviewed were juniors, etc. And then we can actually compare the different groups across the different categories, right? So I can see that the number of freshmen increased at the last game. The number of sophomores decreased. The same goes for juniors, and seniors increased. So that data kind of tells us a little bit more about that. But the thing with bar charts and segmented bar charts is we assume that it's got the same sample size. So that's where a mosaic plot comes in. And we can see here that a mosaic plot actually takes into account the different sample sizes. Meaning, so we can still compare the relative frequencies of both groups. So we can see intro stats, pre-cal, AP cal, and AP stats. But what happens here is we can see that we used a larger sample size for the students than we did the teachers. And so the width of the bars here are adjusted accordingly. So if I had 100 teachers and 500 students, well then the student width of those bars should be 5 times that of the teachers because our sample size was 5 times that of the smaller group. So just some ways here. So we're going to really focus on these 3 here. A bar chart's great, but now you are an AP statistician and actually just a statistician. So we're going to be using some of the tools that we learned about here. So we'll take a 2-way table to find the relative frequencies so that we can create segmented bar charts, and then we'll get spicy with these mosaic plots. So as we're graphing data, I want you to be salty because sometimes it takes a lot of work. And here's what I mean by being salty. I need you to give me a scale. I need you to give me axes, I need you to give me labels, a title, and of course your data. So we call this being salty as we display categorical data. So we're going to use this 2-way table to calculate the total counts of how the grade levels feel on the most pressing issues in schools. So this 2-way table, notice it's not 2 by 2. A 2-way table just refers to 2 categorical variables. So here, the classification of the student and then the issue that they identified. So those are my two variables in my 2-way table. But we can see there's 4 social issues and 3 classifications here. So the total number of students that said peer pressure was an issue, well, 4 plus 2 plus 1 is going to give me 7. Total number of students that said social media was an issue, 2 plus 4 plus 6 will give me 12. And the total that said mental health was an issue is 15, and bullying is going to be 11. Now, that's for my social issues. Let's look at my classifications. 4, 2, 5, 4, that's going to be 15. 2, 4, 6, 3, that's going to be 15. And 1, 6, 4, 4, that's going to be 15. So here's the cool part about it. If we did this correctly, then our total in the sample should add up. So 15 plus 15 plus 15 is 45. 7 plus 12 is 19. 19 plus 15 is 34. And 34 plus 11, you guessed it, 45. So we interviewed a total of 45 total students here. So now that I know this information, from those 45 students, I can tell you how many are a 10th grader and said mental health was an issue. I can tell you how many were an 11th grader and said bullying was an issue. I can identify each of these categories using those frequencies. But what's important now is analyzing this data. So we're actually going to take these counts and we're going to look at it two ways. We're going to look at it in terms of our social issues, and then we're going to look at it in terms of our grade classifications here. So the way we do this, we look at the following. Look at the relative frequency of each variable, which we're going to need to find that. The marginal distribution is the total distribution for that particular value, meaning the total number of 10th graders, total value of 11th graders. The total percentage of students who said peer pressure was an issue, who said bullying was an issue, etc. So the marginal distributions, those are going to be there in our total columns. It's going to be at the end of the columns and the end of the rows. Now the conditional distribution describes the value of the variable among an individual who has a specific characteristic. So when I look here at, let's say, peer pressure, I can break it down by 10th, 11th, and 12th, or I can go vice versa. If I look at 10th grade, I can see which of the issues were the most pressing for the sophomores there. So let's look here and let's calculate our marginal distribution. So peer pressure, we had a total of 7 students. So we're going to have 7 out of 45. And that's going to give us an approximate value. Here for social media, we had a total of 12 out of 45. And I'm going to assume you can kind of figure out the rest here. So I'm just going to give these approximately symbols. In AP statistics, at a minimum, you need a fraction and you don't need to simplify, but you do at least need the fraction. So from here now, I'm going to give some approximations. And what actually I'm going to do is I'm going to have you pause the video and figure these out. But for example, for the 7/45, I'm just going to go with about 15.6%. So I'm only going to use one decimal point here. So what I need you to do is I need you to pause the video, and then I need you to finish figuring out the rest of these percentages, and then based on these percentages, I need you to describe the marginal distribution. So I need you to tell me which social issue was greatest and which one was the least concerned. So go ahead and pause the video and try this out. Alright, so hopefully not too complicated. I found the rest of these percentages here, and when I describe it, I just always want to include context, and that can include just copying the problem again and then adding in the values and terminology. So if I were to describe this distribution, I would say that the largest social issue of concern was mental health for students at this high school at about 33.3%. And then the least social issue of concern was peer pressures for students at this high school at about 15.6%. So notice I'm using greatest and least, and I'm just giving some context behind that. And here, bullying and social media were right in the middle, so you could also add a sentence if you want to comment on that as well. But at the very least, you need to talk about the greatest concern and the least concern. So now let's talk the conditional distribution. So now I'm looking not at the total data set, but I'm looking specifically in each grade level. So for example here, for the sophomores, I had 15 total sophomores. So for peer pressure, 4 out of 15 gave me a value here. 2 out of 15. And so for sophomores, I can say that about 26.7% of them were concerned with peer pressure. And so again, what I'm going to need you to do is I'm going to have you pause the video here and just fill out the table, and then we're going to go through and describe the distribution together. So pause the video and complete this table for the next part. Alrighty, so hopefully your percentages look something like this. I just put a percent here at the top. But when we look at the conditional distribution now, we need to compare across the different issues. So you can do one of two things. You can go by grade level. So you could say for sophomores, the largest issue of concern was mental health, with the least issue of concern being social media. Whereas for juniors, the largest issue of concern was mental health and the lowest was peer pressure. For seniors, the largest issue was social media and the lowest issue was peer pressure. So you can do that, or you can go by social issue. So you can talk about in peer pressure, actually you can't do that because guess what? Our percentages here should add to 100. So up here, notice that in my marginal distribution, they added to 100%. And for each of the grade levels here, they're going to add to 100%. So go ahead and pause the video and just make a comparison within each grade level. So again, you're giving me the largest issue of concern and the smallest issue of concern. So pause this video again and try it out for yourself. Alrighty, so hopefully you were able to fill out these charts here, which I think we already checked, and then give a description here. So this is going by the condition of grade classification. If I wanted to go the other way, the conditions on like the social issue, then I would do things like 4/7, 2/7, 1/7. So I'd say like for peer pressure, sophomores had the largest, identified this as the largest social issue, whereas seniors identified this as the least. For social media, seniors identified this as the largest social issue, whereas sophomores identified this as the least, etc. So you just need to be able to interpret it based on the condition. So whether that would have been classification or social issue. Now let's talk about actually graphing it. So we can do bar charts, we can do segmented bar charts, and we can do mosaic plots. And right now the meme that's popping up into my head or video is that episode of SpongeBob where he gets paint on the dollar bill and Patrick's like, don't worry, we have technology. And he grabs a computer and starts smacking it on his paper. We are in the age of technology, so we are also going to utilize technology. But on the AP exam, remember, we would want to use the SALTI acronym. So for example, here I'd have my axes, I'd give a label of my frequency, I'd give classification, and then I'd give some type of key, which would also go under my labels. And so for that, it would involve things like, peer pressure, social media, mental health, or bullying. And my title would be social issues versus classification. And so then I need to give some counts here. So like 1, 3, 5, 7, 0. And then here would be my sophomores. Here would be my juniors. Here would be my seniors. So that, and you would just fill this in by hand. Now you hear this all the time from math teachers. I'm not an artist. So we are going to utilize technology here. So one very close, one thing that we're going to get in the practice of using is called Statsmedic. They have applets and activities, so you'll see this quite often in our classroom. But you can see here that they've calculated also the marginal distributions, and they also have the conditional distributions. So notice that at the end here, all of the columns add up to 100%. So here's what a mosaic plot would look like. So you can go ahead and copy this down on your paper. And the nifty thing about this is it also tells you the different percentages. So you can see here that we're stacking them up. And my apologies. Let me start off at the basic. Side-by-side bar chart. Here's our sophomores, juniors, and seniors. You can see the variation within each group. So I could say juniors had the largest proportion of students who identified mental health as the main social issue. And then seniors had the largest proportion of students that identified social media as an issue, etc. So I'd kind of just put them next to each other like so. Now, a segmented bar chart would be if I were to take each of these bars here and I divide them by the total sophomores, which is what we did in our conditional distribution. So our segmented bar charts, right, it assumes they're all the same sample size, like so you can compare the categories across each one. And then lastly, our mosaic plot, which would take into account the different sample sizes. But here, since all of our sample sizes were equal, all of the widths of the bars are equal. So side-by-side bar charts, mosaic plots, segmented bar charts, conditional distributions, marginal distributions. You have everything you need to be successful for categorical data. And no worries, we're going to practice plenty in class. But I hope you enjoyed this brief overview of analyzing and graphing categorical data.